Okay, good afternoon. Today we are starting with the third experiment, that is the insertion gain measurement. So this experiment can be performed in two steps. Number one, we have to use a four terminal network, and that is inserted between the source. So source in this case is a function generator, and load. Load is a load resistor. So we can use different values of the load resistor like 1 kilo ohm, 2 kilo ohm, 5 kilo ohm, 10 kilo ohm, etc. Right. So when you vary the input voltage, definitely because of the output characteristic of the amplifier, output may be distorted. Right. So what we have to do in the first step, that when the four terminal network is inserted between the source and the load, so in that case the loss on distorted output is noted down, and the corresponding input voltage, that is denoted by the Vs, must also be noted down. Right, so this is the first step here. In second step, what we have to do, that we have to remove the four terminal network, that is the amplifier in our case. Okay, there is no foundation. You can use the single stage RC coupled amplifier, multi stage RC coupled amplifier, anything is valid here. So in our experiment we are using the four terminal network, that is a single stage RC coupled amplifier. So in step 2, what we are doing, four terminal network is removed. Right, so in that case the source and load must be directly connected. Okay, the output is seen on the CRO screen, and the source is a function generator. So when you connect the source with the load directly, means you have removed a four terminal network. So in that case what will happen, that this will become the parallel combination. Right, so source is directly connected, and whatever is appearing across the source, that can be directly observed on the CRO screen. So what will happen here, that we have to retain the last undistorted output of the step 1 in the second step. Right, so in second step what you are doing, you are retaining the last undistorted output value. Right, so for the last undistorted output value of the step 1, what is the corresponding input in step 2? So that last undistorted output of step 1 is retained in the step 2, and the corresponding value of the source, that is denoted by the Vs dash, is noted down. Right, now take the ratio of Vs dash upon Vs. So 20 log base 10 Vs dash upon Vs is known as the insertion gain. So we have this single stage RC coupled amplifier, and what we are doing here, we are connecting the battery first. So 9 volt of the battery is connected here, positive of the battery is connected to the VCC terminal, and negative of the battery is connected to the ground here. Right, and what we are doing here, we are using the function generator. So we have set its value at 4.44. There is no boundation. You can set the frequency at 1 kilohertz, 2 kilohertz, no problem here. And that frequency we are applying here, that signal we are applying here to the input of our RC coupled amplifier. Right, so 5 microfarad of the capacitor is used here to couple this input, and the R1 and R2 and R3 resistors of 195 kilo ohm and 40 kilo ohm are connected in the voltage divider network here with the NPN transistor. Right, okay, R1 is of 1 किलो ओम वैल्यू, एंड जो बाईपास कैपेसिटर है हमारे पास में, दैट इज़ ऑफ द 68 माइक्रोफेराड, एंड RC हैज़ अ वैल्यू ऑफ 4 किलो ओम, एंड blocking capacitor is of the 5 microfarad. Now we are using the AC 187 type transistor, and common emitter configuration we are using here. So what we are doing here, we are applying the voltage using the 20 volt peak to peak terminal to our input of the RC coupled amplifier, because this RC coupled amplifier is a two port network or the four terminal network that we are using for the measurement of the insertion gain. Right, so now we have the four terminal network inserted between the source. Right, between the source, that is the generator, and we have the load right here. So 5.3 kilo ohm of the load resistor is used here. The output of this combination is connected to the CRO. Right, this is output of the combination or RC coupled amplifier across the load is connected to the channel 1 to the CRO. We observed it for the applied input. The distortion has been observed because when we include the load resistor, so output characteristic of the RC coupled amplifier will change, and that's why we need the 20 dB or the 40 dB of the attenuation, so that the undistorted waveform can be observed on the CRO screen. And with the help of the amplitude variation, we can adjust the value on the CRO screen. That value is coming from the output of the 4-terminal network, that is the RC coupled amplifier. So loss undistorted output is recorded on the CRO screen, and the corresponding input voltage is noted down in your copy. When no attenuation is applied, so we can find that the waveform is observed like this. Right, this is not a sinusoidal, this is not a square wave, this is coming because of the distortion. Right, so what we are doing now, we are providing the 20 dB of the attenuation so that the distortion can be minimized, but still you are able to watch here that the wave shape has changed, but still the distorted waveform is coming from the negative peak. So what we are doing now, we are removing the 20 dB of the attenuation and applying the 40 dB of the attenuation on the screen. Right, so now you are able to watch that the waveform is changed. Now the shape is coming like the sinusoidal, and you can verify that the upper peak and the lower peak both have the same values, right, and both are sinusoidal from both the sides, right. Start. Now to find out the magnitude, what we are doing, we are putting the CRO in XY mode. So when we press the XY mode, we can find that the line will appear here, right. So this line is showing the 0.8 divisions here. So 0.8 divisions are multiplied with the knob of this volts per division, so that is at 1 volt. So let us look at this waveform, right. We have changed the value of the voltage, so this time you are getting the 1.8 divisions. Now when you multiply the 1.8 divisions with the 1 volts per division, because the knob of the volts per division is at the 1, so you will find the value of the 1.8 volt. This scenario you have done under the 4-terminal network connected between the source and the load. When no 40 dB of attenuation is applied, so in that case you can observe the waveform here, and when you press the XY switch, so this is a 1.4 into 1 volts per division, right. So you'll find here the corresponding value denoted by the 1.4 volt, right, when no 40 dB of attenuation is applied. So after the 40 dB of the attenuation, the value of the input voltage Vs will be 0.2 volt. So now we apply the 40 dB of the attenuation, right. So when we apply the 40 dB of the attenuation, we can find here that very low value of the input can be observed, so that is 0.2. So multiply the 0.2 with the 1, so you'll find out the value of the 0.2 volt when the 40 dB of the attenuation is applied. In step 2, 4-terminal network is removed, so source and the load will come directly. This will be a parallel combination, right. So what we have to do here, that for the last undistorted output, we have to find out the corresponding input, and in case of the parallel combination, what will be the input? That will be same as the last undistorted output in case of the step 2. Now that last undistorted output in step 2, we are retaining the value of the last undistorted output of the step 1 in step 2, and we are finding the corresponding input in step 2, right. So that will be the Vs dash, and that will be same as the V0, right. So for V0 of the first step, in V0 in second step will show the value of the Vs dash equals V0. So using the formula of insertion gain equals 20 log 10 Vs dash upon Vs, we write a value of Vs dash equals 1.6 volt, right? And without the attenuation of the 40 dB, Vs was the 0.2 volt. So if you take the ratio of 1.6 upon 0.2 with the 20 log base 10, you can find out the value of approximately 18 dB in this case, when the value of the resistor was 5.5 kilo ohm, right? So 18 dB of the attenuation has been 18 dB of the insertion gain can be observed when you insert this circuit, right? When you insert this circuit, right? And if you change the value of the load, so you are free. The procedure can be repeated with the 1 kilo ohm of the resistor as well as with the 10 kilo ohm of the resistor, and you can find the variation in the insertion gain. So this insertion gain is a function of the load resistor. Now if your formula is able to give the negative value, right, so that will be the insertion loss. So this is the procedure, complete procedure of measurement of the insertion gain. Thank you.